Yeah, I am Srinivas Reddy, head of the Department of Mathematics and Statistics. So I will going to today discuss about the topic orthogonal sets. So today I have introduced first what is the definition of orthogonal sets. So now you have let us assume one set of vectors. Let set of vectors are u1 bar, u2 bar, so on up bar. There are the set of vectors are given. When you find the vectors, if you write as a orthogonal, compulsory ui bar into uj bar is equal to 0 when I not equal to j. So what I write? The set of vectors u1 bar, u2 bar, so on up bar belongs to R power n, then the orthogonal of the vectors ui bar into uj bar is equal to 0 when I not equal to j. So in the case if you write ui into uj, when the I is not equal to j equal to 0, it is called as a orthogonal set. For example, if you determine all the A, B, C are the three problems are there, you have to discuss about A, B, C problems. So first I will go for A, determine the given set of vectors are orthogonal or not, you have to verify. So now I will take, let us assume in the set A, I will take, let us assume, let the set of vectors are given u1 bar is equal to -1, 4, -3 and u2 bar is equal to, I will take 5, 2, 1 and u3 bar is equal to, I will take 3, -4, 7. So this is the set of vectors are given. So now this set of vectors, how many possibilities of the product you have to check out. So there are the given three vectors are there, you have three possibilities are you have. So you when write u1 bar into u2 bar, one possibility, and another possibility is u2 bar into u3 bar, this is the product of possibility, and another one is u1 bar into u3 bar is also one of the possibility. So these three possibilities you have required the product, if you equal to 0, therefore the set of vectors are orthogonal. So now u1 bar into u2 bar is equal to, I will write in the inner product, the formula is u1 bar transpose into u2 bar. And in the same way, in the u2 bar transpose into u3 bar, it is equal. Then again u1 bar transpose into u3 bar. So now u1 transpose into u2 bar, why it is u1 transpose into u2 bar? If you are given here, there is a number of rows are, here the number of rows are 3 and column is 1. Here also number of rows are 3 and column is 1. Here also number of rows are 3 and column is 1. But if you want the product, compulsory here columns and rows are equal, you will go for the product directly. If we are not equal, that's why I will write as a transpose matrix. So now u1 bar transpose means what I write in the right as a column goes to the rows. So I will write here -1, 4 and -3, right on the column goes to the rows, and I will write again 5, 2, 1. So now write the product in this. Now here the how many columns is here? 3 columns, sorry 3 rows and 1 row and 3 columns. Here is 3 rows and 1 column. So what I do now, this is the product is column is 3 and rows are 3, then only I multiply the product of the matrices. So now 3 and 3 is equal, that's why it is a number of columns are 3, number of rows are 3, then you multiply directly -1 into 5, -5 into -1 into 5 plus 4 into 2 plus -3 into 1. -3 into 1. So now you can write here equal to -5 plus 8 -3. -5 -3 -8 plus 8 equal to 0. Then go for the second one, here u2 transpose again. Another pair u2 bar into u3 bar pair. You will take again here the columns into write as row. So that is column write as row into here multiply 3 -4 7 is equal to 5 into 3 plus 2 into minus 4 plus 1 into 7. How much you will get? 5 3s are 15. Here is minus 8. Here is plus 7. How much now? Plus 7. So 14. Here how much now? 5 minus 2 equal to 0? No. That is 15 plus 7. How much? 15, 8. 22. 22 minus 8. 14. 14 is not equal to 0. Then go for the another pair. You go for the another pair now. 3 into 3 minus 4. Sorry, first you write as a U1 transpose minus 1. Minus 1, 4 minus 3. Into you write 3 minus 4, 7. That is equal to, write the product now. Minus 1 into 7 plus minus 1 into 3 plus 4 into 4 minus 4 plus again minus 3 into 7. How much now? Minus 1 minus into 3 minus 3 minus 16. All are minus only, na? You will get 40 minus 40, right? 21 16. 21 16 is 37. 21 16 37. 37 plus 3 minus 40. It is also not equal to 0. So what do you write the conclusion? U1 transpose into U2 transpose equal to only 0. The pair is 0. Other than these two pairs are not equal to 0. So therefore what do you write now? The statement is, therefore U1 bar into U2 bar are orthogonal, but the set of U1 bar, U2 bar, U3 bar not an orthogonal. Orthogonal in R power 3, na? Yeah, R power 3. So now U bar and U1 bar and what do you write? U1 bar and U2 bar are orthogonal in R power 3. Then but here U1 bar and U2 bar and U3 bar is not an orthogonal in R power 3. This is the first A bit. So now in this case you have the number of pairs you have to identify first. How many pairs you are having the given set. You have the number of pairs are here, 3 vectors are given, 3 pairs are available. So that you write in the 3 vectors. Now this is the 3 by 3 matrices. Here also 3 by 3 matrices and here 4 by 4 matrices. Here is 3 by 4 matrices. There is a 4 by 3. That means 4 rows are there, 3 columns are there, 4 by 3 matrices you will get. So now in this particular third bit, C bit, I will go for the directly C bit. You practice in the B bit. So you can practice it B bit. I will go for the third bit. Then you write as here 3 U1 bar is equal to, I will write as 3 minus 2 1 3 and U2 bar is equal to minus 1 3 minus 3 4 and U3 bar is equal to, write as 3 8 7 0. These are the 3 vectors are given. Again you do the properties. U1 bar into U2 bar, you write possibility, and U2 bar into U3 possibility, and U3 bar into U1 possibility. Whatever you write is the equal either product 2 into 1 or 1 into 2 or 3 into 2 or 2 into 3 or 1 into 3, 3 into 1. Whatever you write the product. So it is a basic idea. U1 transpose into U2 bar. Then you write as U2 transpose into U3 bar and U3 transpose into U1 bar equal. So again you do this. Now the same way, this is also here. The number of rows are 4. The number of columns are 1. 4 into 1, 4 into 1, all this. So that's why you write as transpose. So now you transpose here means what I write in this transpose 3 minus 2 1 3 transpose here, that is how many columns is here? 4 columns 1 row, 1 into 4. Then another one is here minus 1 3 minus 3 4. This is 4 into 1. So now it is equating them. See, observe this. Right? The columns and rows are equal, then only you have multiplied. Other than if you not multiply the matrix multiplication. In the same way, you have to do this in this problem now. 3 into minus 1 and plus minus 2 into 3 plus 1 into minus 3 and plus 3 into 4. 3 into 4. So you can calculate this. Minus 3, minus 6, minus 3 and plus 12. How much now? This is minus 12 plus 12 equal to 0. So first u1 bar into u2 bar is 0. Then go for the, in the third one, we go for the, I will take the duster from this. So now we'll take now u2 bar into u3 bar, we'll take the next one. So u2 bar transpose into u3 bar, u2 transpose is here minus 1, 3, minus 3, 4. This is 1 into 4 column, then again 3, 8, 7, 0, then here 4 into 1, again will be here and same. So we can go for now minus 1 into 3 plus 3 into 8 plus minus 3 into 7 plus 4 into 0. 4 into 0. How much now in this? Equal to 0. Then go for last one, u3 bar into u1 bar, that is equal to u3 bar transpose into u1 bar is equal to, again you write here u3 bar is 3, 8, 7, 0. It is also 1 into 4. Then multiply here. 1 is here. 3 minus 2, 1, 3. Right, multiply. So I will go for in this. So now that is equal to here 3 into 3 plus 8 into minus 2, 8 into minus 2 plus 7 into 1 plus 0 into 3. So how much now? 9 minus 16 plus 7 plus 0, that is equal to 0 again. So what I write now? All the vectors are orthogonal vectors. So therefore the set of u1 bar comma u2 bar u3 bar are orthogonal. Orthogonal in r power 3. That's it. These are the first question and third question you have to solve for the orthogonality. Whenever it is a given, the same type of problem in the examination also you can do this. The number of pairs you have to identify, how many pairs you have available, you can product, you have to do that problem in the orthogonality, right? So this is one of the major important of the subject in the orthogonal sets in 4th unit, right? So here the case is here the inner product of the two vectors. So that is the basic idea is orthogonal set. Orthogonal set means it is called as a perpendicular sets. It is called as a perpendicular sets. The number of vectors are given, you have to mention how many vectors are given a set. For example, 4 set of vectors are given. How many possibilities you have to check? u1 and u2, u2 and u3, u3 and u4, again u1 and u4. Like that, how many possibilities you have to check. So these, for example, I will give you 4 vectors are given. u1 bar, u2 bar, u3 bar and u4 bar. So there are the 4 vectors are given in a set. So possibilities, u1 into u2, one possibility, u2 into u3, another possibility, u3 into u4, another possibility, and u1 and u4 is possibility, u2 and u4 is also possibility, right? So how many are there? 5 are there. u3 and u1 also is there, 6 are there. So that means here 6, u3 and u1 also. So there are the number of possibilities you have to check, how many possibilities you have. If your set is increases, the number of possibilities also increases. So these are equal to 0, so all are equal to 0, therefore it is a given set is a orthogonal set. Okay, it's clear? So that is a orthogonal process. So in the orthogonal process you have given. So what is the orthonormal sets? It is another one. It is orthonormal set. It is a long type of question. This is a short type of question. This is a long type of question. Orthonormal sets. This is another definition. So in this orthogonal is you have identify all are equal to zeros. Therefore it is called as a orthogonal sets. If in this case orthonormal sets means if a given set of vectors, if a given set of vectors are given same in this set of vectors are given, let us assume in the set of vectors u1 bar and u2 bar so on up bar is given, the set of vectors belongs to R power n. So once it is a set of vectors are given, so again the same, where the orthonormal sets means compulsory orthogonal of unit vectors. Orthogonal of unit vectors is called as a orthonormal sets. So what is the meaning of that? Orthogonal is compulsory. Again you want unit vector is also compulsory. These two properties are satisfied, therefore it is called as a orthonormal sets. So in this particular idea is here ui into uj is equal to 0 if the case I not equal to j. This is the orthogonal property. So after that, and one more property is also satisfy, ui bar into uj bar is equal to 1 if I is equal to j. If I is equal to j. So these two properties, what is the meaning of that? Once you get the orthogonal set, that set of vectors as well compulsory, you have follow the unit vector. Unit vector is also satisfied, therefore it is called as a normal, orthogonal normal sets. So now these two sets are these two conditions are satisfied, it is called as a orthonormal sets. So this is a particular you have to write in the same questions are given. For example, the set of vectors are 3 is given. So again you write the possibilities of these 3 vectors. These possibilities of 3 vectors which are the equal to 0, which are equal to 1. Therefore it is both are satisfied, therefore it is called as a orthonormal sets. Is it clear? So these are the two conditions are very, very important for the orthonormal sets. So now I am going to one problem in this regarding orthonormal sets. So I will go for one problem in this orthogonal sets. Already I gave a small practice problems in your class. So again I will do this problem, and this is also important one. So I will write the problem. Now in this case, if V1 bar is equal to, I will write 3 by root 11 and 1 by root 11 and 1 by root 11. This is a one vector. V2 bar is equal to, I will give one more vector, minus 1 by root 6, 2 by root 6 and 1 by root 6. And third vector, V3 bar is equal to, third vector, minus 1 by root 66, minus 4 by root 66 and 7 by root 66. These are the 3 vectors. Show that the set of V1 bar, V2 bar, V3 bar is an orthonormal basis. Is an orthonormal basis. Basis in orthonormal basis in R power 3. R power 3. So now this is a required one of the important question for last time it is given in the external examination. So the same problem is given in the external examination. So now we are going to 3 vectors are given, the set of vectors are 3 is given, show that it is a orthonormal basis in R power 3. Here one word is extra word is will come here, basis. Basis means you have compulsory linear independent and linear span of the vectors. So if the once you get the orthonormal sets here, the find out it is equal to 0, all are equal to 0, it is called as a linear independent. Once it is a linear independent, the set of 2 product vectors, every orthogonal vectors are called linear independent. So that is the reason for linear independent. It comes on the basis. How many vectors are equal to 0? So you have to check out those vectors are basis. So that is called as dimension. How many bases are there in a set? You will call as dimension. So this is a major role in this orthonormal basis. You have to go through this problem. Now it is an important problem. So in the possibilities, again in the same set, given set of vectors are given. So first you write given set of vectors v1 bar, v2 bar, v3 bar is belongs to R power 3 given vectors. So in that vectors you have two possibilities, v1 bar into v2 bar possibility, and v2 bar into v3 possibility, and v3 and v1 possibility. v1 bar into v3 possibility. So now you have to check this v1 bar into v1 bar transpose into v2 bar to check out these values. Now this is transpose means 3 by root 11, 1 by root 11 and 1 by root 11. So here into v2 bar is here minus 1 by root 6, 2 by root 6 and 1 by root 6. Check out this. Just it is a product. Write the product here. Number of rows are 1, number of columns are 3. Right? Here in number of rows are 3, number of columns are 1. You have identified. So here the number of columns, the number of rows are equal, then only you have multiply the matrices. So now in this, that is the inner product, 3 by root 11 into minus 1 by root 6 plus again 1 by root 11 plus 2 by root 6 plus 1 by root 11 plus into 1 by root 6. 1 by root 6. See, observe this. All these multiplication, 1 into this, 2 into this, 3 into this. Right? So it equal 3 into minus 1 numerator, 3 into minus 1 minus 3 divided by root under root of a into under root of b, root of a into root of b. What is the formula? Root a into root b, that is equal to root to ab, right? Root ab. So you can write as under root of 11 into 6, 66 plus here 1 into 2, 2 by 11 into 6 again, root 66 under root 66 plus 1 by under root of 66. See, observe this. All denominators are same. LCM is also same. Only numerators are adding. So what you get in that? The LCM is root under root of 66 minus 3 plus 2 plus 1. 0 by something, 0 is equal to 0. So this is the product of V1 bar into V2 bar, product is equal to 0. Again similarly you have to find out these two, V2 bar and V3 bar. So you can go for V2 bar and V3 bar. I will go for in V2 and V3 bar. So V2 bar transpose into V3 bar is equal to, so V2 bar is minus 1 by root 6 and 2 by root 6, 1 by root 6 into V3 bar minus 1 by root 66 and minus 4 by root 66 and 7 by root 66. So now you are going for that, show that these bases are verified. So that is equal to minus 1 by root 6 into minus 1 by root 66 plus 2 by root 6 into minus 4 by root 66 plus 1 by root 6 into 7 by root 66. See, observe this. Here minus 7 by root 66. 7 by root 66. So now 1 by root 6 into root 66. Don't multiply unnecessary. Why you have multiply unnecessary? Minus 8 by root 6 into root 66 plus 7 by root 6 into root 66. All bases are, all denominators are same. Take the LCM same. We will take LCM same. Root 6 into root 66 LCM. 1 time minus 8 times plus 7 times. Right? It is also 0 by something. It is also 0. Right? So now this is a way of using this. So next, last one, V3 or V1. V1 bar into V3 bar. So V1 bar transpose into V3 bar is equal to, so V1 bar transpose means what I write? V1 bar 3 by root 11, 1 by root 11, 1 by root 11, and into V3 bar. V3 bar you can take, what is the V3 bar here? V3 is here minus 1 by root 66, minus 4 by root 66, 7 by root 66. 7 by root 66. Write correctly here. 7 by root 66. So multiply again here. Same. 3 by root 11 into minus 1 by root 66 plus 1 by root 11 into minus 4 by root 66 plus middle term is plus 1 by root 66, root 11 into 7 by root 66. Observe this, same product, same denominator product. We'll apply here minus 3 by root 11 root 66, right, and plus minus 4 by root 11 into root 66 plus 7 by root 11 into root 66. No need you multiply inside. Okay, you can directly in the same picture in the denominator. So here under root of 11 under root of 66. So that is minus 3 minus 4 plus 7 minus 7 plus 7, 0 by something again. Root 66 equal to 0. So what do you write now? Conclude in this, the set of V1 bar, V2 bar, V3 bar are orthogonal. Orthogonal set. Right? So this is the orthogonal set. So now in this set, you have to write as one more. In this orthogonal set, it is satisfied unit vector. These vectors satisfy again unit vector. What is the meaning of unit vector? So compulsory here, V1 into V1 bar is equal to 1. V2 bar into V2 bar is equal to 1. V3 bar into V3 bar is also 1. So what is the difference from there to here? Here is the same vector multiply. There is no same vector multiply. That is the reason. Here is same vector multiply in the product, the pair of product. So V1 bar into V1 bar, V2 bar into V2 bar, you have to multiply V3 bar into V3 bar. So now in this vector, you have to satisfy orthogonal sets. So now you are going to V1 bar into V1 bar is equal to V1 bar transpose into V1 bar. So V1 bar transpose I will write here. What is the V1 bar is here? 3 by root 11, 1 by root 11, 1 by root 11. Same product multiply with column. 3 by root 11, 1 by root 11, 1 by root 11. See, observe this. 3 by root 11 into 3 by root 11 plus 1 by root 11 into 1 by root 11 plus 1 by root 11 into 1 by root 11. So now here 3 into 3 in numerator 9, root a into root a square, root a squares. You know that formula. You know about that formula is here root a into root a is equal to root of a square. The square root square cancel, a only you will get. That is 9 by 11 plus 1 into 1, 1 by 11 plus 1 by 11. So how much now numerator? LCM is 11. 9 plus 1 plus 1. 11 by 11. 1. You will get 1. So this is a required unit vector. Right? In the same procedure you have write V2 to V2, V3 to V3. Once you satisfied, therefore it is called as orthonormal sets. Okay. So in this way you have to think V2 bar into V2 bar. Again I will do the another one. So V2 bar transpose into V2 bar. So that is equal to V2 bar is what? Minus 1 by root 6, 2 by root 6, 1 by root 6 into again minus 1 by root 6, 2 by root 6 and 1 by root 6. So now you can equal minus, you have just product minus 1 by root 6 into minus 1 by root 6 plus 2 by root 6 into 2 by root 6 plus 1 by root 6 into 1 by root 6. You can take these values now. So here minus 1 into minus 1, 1, root 6 into root 6, 6, plus 2 into 2, 4 by 6, plus here 1 into 1, 1 by 6. So how many are there? 6, 1 plus 4 plus 1 is equal to 1. Right? So V2 also satisfied. Last one is here, third one, V3. So I will go for V3. This is a long type of question. V3 bar into V3 bar is equal to V3 bar transpose into V3 bar. So you can write as V3 bar minus 1 by root 66 minus 4 by root 66 plus 7 by root 66 into the same product minus 1 by root 66 minus 4 by root 66 7 by root 66. So you can write here minus 1 by root 66 into minus 1 by root 66 plus minus 4 by root 66 into minus 4 by root 66 plus 7 by under root of root 66 into 7 by under root of root 66. Now that is equal to here 1 by root 66 only minus plus 16 by 66 plus 49 66. Count it 50 plus 16 66 by 66. So therefore what do you write? All the ortho unit vector also satisfied. So conclude you write. Conclude is most important. You write the after completion of the question of the answer you write compulsory conclude, include or conclude. You write here set of V1 bar, V2 bar, V3 bar are orthonormal sets in R power 3 and is linearly independent and dimension is 3 and also form a basis in R power 3. This is a conclude. So if a given set of all three vectors are orthonormal sets in R power 3 and is linear independent and a dimension is 3 and a basis is also satisfied in a R power 3. Right? This is a clear picture of the orthonormal sets. Whatever questions are given in this problem, the same type orthogonal, orthonormal. Right? In the examination also you can do this. This is a long type of questions. Okay? It is very, very important. Thank you.